name is Igor. I am currently completing my doctoral studies with a focus on smart homes. My research is focused on improving security and speeding of communication in smart home environments, utilizing mesh network and the ZigBee protocol. In the current study, we have in holistic integration of ZigBee technology for optimized sensor calibration in wireless sensor network. We have developed a solution to accelerate the sensor calibration process using a mesh network. Traditional the calibration process requires physical intervention as the sensor must be removed, disconnected, and transported to laboratory. But by implementing our approach, we reduce time consumption and eliminate. You don't need to disconnect the sensor from its operation, enabling continuous monitoring during that calibration process. Let's start. I said about this system. This is a wireless sensor network. In this system, sensors are divided into nodes, and each node performs two functions, receiving and transmitting data. There are two types of nodes, sensor nodes and coordinator nodes. Sensor nodes are responsible for collecting environmental changes, while coordinator nodes are tasked with delivering the data to the end user. VCN system were initially used for military purpose, but after that they use in different type, like civil example for geo fencing or gas or oil pipelines, environmental monitoring, healthcare, and etc. Um, the protocol used in research is ZigBee, which specifically designed for transmitting short messages between nodes in VCN system. It operates on low power, low data rate standard, making ideal for energy efficiency. ZigBee architecture supports long distance communication through the mesh network, allowing data to be routed across the multiple nodes, which increases range, scalability, reliability. Some of main advantages is that, and this system can be extendable. You see on the picture some type of ZigBee system, and most usage is what I research on Doctor. It's smart home and smart cities. That's now like popular, and that's commercial product. We have, in addition to mesh topology, which has the widest usage, there are also star and tree topologies. The difference is in communication between nodes. In the star topology, communication happens only through the coordinator nodes. And we have a ZigBee coordinator is like this. This on a picture is mesh topology, but in star topology we have several coordinator. In tree topology we have one coordinator nodes, and communication based on that single node. This is just some basic about these protocols and VCN system, and let's go on our research. For the purpose of the search, different type of nodes have been created. Like you see on the picture, we have a main node, a reference node, and regular nodes. The main nodes also serves as the entry point into the system, and all data is stored there. The reference nodes has occasional role in the system and is necessary for calibration process. while the remaining are regular nodes that perform daily measurement in the system and communication with each other. Uh, Big number of nodes is regular nodes, reference nodes. It's just occasional, and they are removed from the system. But I talk about later. All the node type mentioned on the previous slide are stored in a table of dynamic states, uh, which serves to describe the role of each node in the system. For that table, we have a structure, and we want to know the node address, their node type, because all nodes have a sensor on it, and we want that maybe it's for measurement of weather or something else. Uh, Proposed function, it's we have a description of that, routing time, and status. Nodes can have a status of being in one or two states, active or deactivated, and if nodes is out of service for a certain period, it's automatically removed from the system. Uh, we don't want to have that node in a future routing process. Uh, when a new node is added to the system, it's automatically inserted in the table of dynamic states and assigned its role. Most nodes in the system are regular nodes, what I said, while reference nodes appear occasionally and are removed from the system once their function is completed. Storing this table on the main node improves access and analysis as all data is located in one place. Through routing in the system, nodes are dynamically added, and the status of each node can be changed in real time, which is advantage of working with this type of communication. In the system, in addition of table of dynamic states, we must create and implement a table of sensor parameters, which stores all measurements from the nodes in the system. The parameters are stored on the main node, same like a table of dynamic states. Uh, Based on this table, it's possible to create measurement history for each node and identify deviation in sensor from performance under different conditions, such as change in temperature, humidity, or environmental factors. They may affect sensor accuracy or behavior. Table structure of table of sensor parameters. We must need address of the node, type of the measurement, time of the measurement, because we want history of that, and the value of the performed measurements. Uh, Deviation in sensor performance and calibration are determined based on the parameters recorded by the reference node, which are stored in a centralized parameter table in the main node. These parameters of the reference model are compared with those from the regular nodes in the system, and the resulting deviation are calculated. This deviation data is then used to the correct measurements from the regular nodes, ensuring more accurate readings in the future. This calibration model significantly accelerate the entire calibration procedure and operates wirelessly, eliminating the need to disconnect the sensor like on traditional way or take them offline during the process. After each measurement, the system dynamically adjusts all parameters in real time, which ensures continuous adaptation to change in environmental conditions. This approach not only speeds up the condition process, but also reduces the probabilities of errors. And system is more reliable and efficient in real-world application when work. And this of sensor calibration, they have more advantages, but key of advantages because allow multiple nodes to be calibrated in the same time, and it's improving efficiency of this process. And in this calibration, when we stored in a table of parameters on main node, we can we can have a measurement history, and we can know deviation of all sensors in a system. Okay, for future results of this research, we will focus applying to propose concept in various real-world conditions to maybe evaluate its performance across different environments and identify any potential challenges. And this allow us to refine the system, and we can fix any issues that may arise during operation. Based on these findings, further improvements will be made to optimize the calibration process, and we can improve the system's efficiency and ensure that model of research can be effectively implemented in everyday application. And our goal of this research to make this calibration model more adaptable, reliable, and suitable for widespread use in real world. Maybe